Section 3.5, graphs and applications of functions, and we're going to have a whole lot of word problems. Just get ready for it. Word problem city. Here it is. We've got a restaurant. We want to make sure that there is this storage area that's kind of blocked off from the customers. And the real question is, how can we arrange this partition so that we get the most storage space out of it? We've only got 20 feet of partition, as you see in the word problem. Let's just read that right now. Storage area. Jenna's restaurant supply store has 20 feet of dividers with which to set off a rectangular area of the storage overstock. If a corner of the store is used for the storage area, the partition need only form two sides of the rectangle. I just want to point out that this is going to be very similar to other situations. For example, a farmer has, you'll see these kinds of word problems later on in the assignment. A farmer wants to build a fence for his cows, and there are the cows on the inside. They're penned in by a rectangular fence, but there's water over here as a stream. So you really only need to build a length and then two widths of a rectangle. Only three sides of this rectangle. Here, there's only two sides of this rectangle in this particular problem. What we need to do is a four-part problem. You need to express the area as a function of length. We need to find the domain, the graph, and the dimensions of the maximum area. This is totally different from any other word problem you've seen so far, because normally what we do is we solve. And we're really great at solving. We're given an equation with one variable, and then we get the answer x equals 1. Great. Or sometimes we're given two equations with two variables, and we can still solve there. But here, what we're doing is we need to maximize, and that's different from solving. What we need to create is an equation, one equation, and we're not going to be given enough information to get down to like one equation with one unknown. That way we'd be able to solve it. What we get is an equation, one equation with two variables that we have to maximize. And we have to maximize by graphing it. So you'll see, we'll digest all of our information and eventually get down to one equation with two variables, and we can graph that. You can graph it by paper if you want, but it's really fast on Desmos, and then you can find the maximum. The answer is going to be the maximum point, or sometimes the minimum point, depending on the word problem. So the goal is going to be to focus our energies and get down to one equation with two unknowns. And this y value is what we're going to have to be maximizing. Pretty sure most of the problems in the textbook are going to be asking for a maximal area. You can see maximum area. So the knowns and unknowns, we know, for example, that the length plus the width is equal to 20. How do I know that? It's here. We've got 20 feet worth of partitions. We also know the formula for area, which is length times width. What don't we know? Well, we don't know the maximum area. We don't know the width and the length. But let's focus on this maximal area. This is the function that we're eventually going to need to graph and maximize, area. The only problem with that is that we've got two variables and not one. We need to get it down to one. Well, I know we can use this other fact here. Part A says express the area as a function of length. And so it's almost there. Like, look, it's area as a function of length. But what's this W? We've got to get rid of it. How are we going to get rid of it? We're going to use the other known that we have. So this becomes, here, we can figure out what W should equal. Subtracting L from both sides, we get 20 minus L. And let's plug that back into the area equation. We get area is equal to L times no longer W, but what W is equal to. It's equal to 20 minus L. All of a sudden, this is a function that we can graph. It's got one variable here. This is like the y, and then you've got x, and then times 20 minus x. You could graph this if you wanted to on Desmos. And in fact, we will. This is what we're going to maximize. This is a function that is maximizable, and you can find the maximal area.